Greetings of the day to all of you. I welcome you all to another lecture on power quality problems and solutions. We have started a series of lectures on various three-phase systems like three-phase balanced system, three-phase unbalanced system, three-phase balanced system with harmonics, and three-phase unbalanced system with harmonics. In this series of lectures, we have already analyzed in our previous couple of lectures a three-phase sinusoidal balanced system where voltages are sinusoidal, currents are sinusoidal, system is completely balanced. And we derived some very important results. First result is that the instantaneous power or active power is constant in case of a three-phase balanced system, and that is equal to VI cos phi. And instantaneous reactive power is also constant, that is equal to VI sin phi. Now, in today's lecture, we are going to discuss three-phase unbalanced system, part B. Three-phase unbalanced system. Now, let us assume that the three-phase system is not balanced, it is unbalanced. Now, what are the causes of unbalance? First of all, when I say unbalanced system, you must understand that unbalance means the magnitudes are not same. That is, current magnitudes or voltage magnitudes, they are not equal in all the three phases. Or there may be unbalance in the phase angles. What are the causes of these this unbalancing? One of the main causes of unbalancing is single phasing. Like, say for example, you are feeding a three-phase load, suddenly one phase gets, one phase blows. The fuse of one phase blows. The three-phase load is fed from only two phases, so that causes three-phase unbalance. Other causes are faults like single line to ground fault, line to line fault, line to line ground fault, so on. And third main cause is arrangement of different loads on three phases. I mean, if you have a three-phase four-wire system, star connected system of course, and this three-phase four-wire system is feeding single-phase loads, then you are not uniformly distributing single-phase loads on all the three phases. So different loads are put on different phases, so that will cause unbalance in currents, load currents, and that will result in unbalance in voltages. So here we will take two cases. Case A or case 1 will assume that there is unbalance in both voltages and currents. Both voltages and currents are unbalanced. That is, both quantities are unbalanced. This is first case. Okay, now let us assume the three-phase voltages are given by VA is equal to root 2 VA sine of omega t minus phi VA, where phi VA is the phase angle of phase A. Then phase to neutral voltage or phase voltage VB is equal to root 2 into capital VB, where this capital VB is RMS value and this small VB is instantaneous value. So root 2 VB sine of omega t minus 120 degrees minus phi VB. Phase voltage VC is equal to root 2 VC sine of omega t plus 120 degrees minus phi VC. So this is a set of three-phase voltages. What will be the set of three-phase currents? The three-phase currents are IA, phase current or line current IA is equal to root 2 into capital IA, whereas capital IA is the RMS value of line current and small ia is instantaneous value of line current. So IA is equal to root 2 IA sine of omega t minus phi IA, where phi IA is the phase angle of current IA. IB is equal to root 2 IB sine of omega t minus 120 degrees minus phi IB, and line current or phase current IC is equal to root 2 IC sine of omega t plus 120 degrees minus phi IC. So this is the set of three-phase currents, line currents. So you can see the RMS value of three-phase voltages VA, VB, VC, they are not equal. So VA is not equal to VB, not equal to VC. So there is unbalance in the current voltages. There may be unbalance in the phase angles also. Or let us forget about phase angles. Let us assume that there is unbalance in the voltage magnitude. So VA not equal to VB, not equal to VC. Similarly, the three line currents are not equal. So IA is not equal to IB, not equal to IC. Whereas in balanced system, they were equal. Okay. Now, what is three-phase instantaneous power given by? Let us write the mathematical expression for three-phase instantaneous power. So I will write here three-phase instantaneous power, which is delivered from source to load, instantaneous power. It is given by PT is equal to VA into IA plus VB into IB plus VC into IC. Or we can say P three-phase T is equal to PT. Three-phase instantaneous power is equal to, what is VA, instantaneous voltage, phase voltage VA? It is root 2 VA sine of omega t minus phi VA, right? Into IA. IA is root 2 IA sine of omega t minus phi IA. So that is the product of phase voltages VA and current, phase voltage VA and phase or line current IA. VA into IA. This is VA, this is IA. Plus power in phase B is VB into IB. What is VB? Equation for VB, it's root 2 VB sine of omega t minus 120 degrees minus phi VB into IB. IB is root 2 IB sine of omega t minus 120 degrees minus phi IB. So this is the power carried by phase B. Now what is power carried by what is power carried by phase C? It is the product of phase C voltage and phase C current, VC into IC. So plus we know that VC is root 2 VC sine of omega t plus 120 degrees minus phi VC into IC. IC is root 2 IC sine of omega t plus 120 degrees minus phi IC. So that is it. This is the three-phase instantaneous power in a three-phase unbalanced system when both voltages as well as currents are unbalanced. Okay. Now this power is given by, it can be further written as, now root 2 into root 2 is 2. So I will write it as VA IA into root 2 into root 2 is 2 sine of omega t minus phi VA into sine of omega t minus phi IA, right? That is phase A power. What about phase B power? Plus phase B power is VB into IB. So product of RMS value of voltage VB and current IB into root 2 is 2. Then sine of omega t minus 120 degrees minus phi VB into sine of omega t minus 120 degrees minus phi IB. Fine. Plus phase C power now. VC into IC. That is VC IC. Then root 2 into root 2 is 2. Then first term sine of omega t plus 120 degrees minus phi VC into, then second term is sine of omega t plus 120 degrees minus phi IC. Okay. So this is, let us call this equation as equation 1. This is instantaneous power in a three-phase system. phase A instantaneous power in phase B, and instantaneous power in phase C, the sum of the three phase powers. Now we know this trigonometric identities. This, see, in all the three equations there is 2 sine A sine B, 2 sine A sine B, 2 sine A sine B. We know this trigonometric identity 2 sine A sine B. It is given by cos of A minus B minus cos of A plus B. Let us use this trigonometric identity and put it in equation 1 and try to simplify this equation 1. And let us do one thing. Now this, as far as first term of equation 1 is concerned, it is VAIA multiplied by 2 sine A sine B. Okay. Then plus second term is VBIB multiplied by 2 sine A sine B. Then third term is plus VCIC multiplied by 2 sine A sine B. Okay. Now as far as this trigonometric, this term is concerned, 2 sine of omega t minus pi VA into sine of omega t minus pi IA. Let us call this term as term A. Similarly, the trigonometric term in this second term, let us call this B. And this 2 sine of omega t plus 120 degrees minus pi VC into sine of omega t plus 120 degrees minus pi IC. Let us call this C. So let us compute now or simplify terms A, B and C. And then after computing and simplifying these terms, term A, term B and term C, which are nothing but these trigonometric identities, using this trigonometric identity, 2 sine A sine B is equal to cos of A minus B minus cos of A plus B, we'll put the computed and simplified terms A, B and C back into equation 1 and we will get the final result. Now A is equal to, what is A? A is 2 sine of omega t minus phi VA into sine of omega t minus phi IA, omega t minus phi IA. That is 2 sine A sine B. And we use this trigonometric identity, that is 2 sine A sine B is equal to cos of A minus B minus cos of A plus B. So this is equal to cos of A minus B. A is omega t minus phi VA minus B. B is omega t minus into minus is plus phi IA minus cos of A plus B, second term, cos of A plus B. A is again omega t minus phi VA plus B. B is omega t minus phi IA. Fine. So let us further simplify this. So A becomes equal to cos of, now this omega t and omega t goes. So this is phi IA minus phi VA minus cos of omega t plus omega t is 2 omega t minus, then we have phi IA minus phi VA. Okay. Now let us call this phase angle. What is phi IA minus phi VA? It is the phase angle or phase difference between line current or phase current IA and phase voltage VA. This is the phase, let us call this phi IA minus phi VA. Let us call this equal to phi A, where phi A is nothing but it is the phase angle by which current in phase A or line A lags behind the phase voltage VA. So IA lags behind VA by phi. So from this you can find phi IA. If you find phi IA, that will be equal to phi A plus phi VA. So substituting these two equations in this equation, what you get? Let us see what we get. A is equal to, therefore, A is equal to cos of, what is phi IA minus phi VA? We assume, we call it phi A minus cos of 2 omega t minus phi IA. And what is phi IA from this equation equal to? It is phi A plus phi VA. It is phi A phi A plus phi VA minus phi VA. Okay, hold on. Some phi IA is phi A plus this. So this is 2 omega t minus phi a minus phi va minus phi va. Okay, fine. Yeah, it's okay. So it is cos of 2 omega t minus phi ia minus phi va. By the way, what is minus phi a? Minus phi a is minus phi a minus phi va. Because we have minus here, so both these terms will become minus, and then we have our own phi va. So therefore a will be equal to cos phi a minus cos 2 omega t minus this is phi a minus 2 phi va, because it is phi va minus phi va, that is minus 2 phi va. So let us do one thing. We write it like this: cos phi a minus cos of, let it be minus 2 omega t. This positive we can make negative, this minus will become plus then, and this minus will also become plus. Okay, so because cos of minus theta is cos theta itself, that is not going to make any difference. So this is equal to cos phi a minus cos of, what I can do is that I can write first this phi a, then I can take this minus out and I can write 2 omega t minus 2 phi va. Okay, so a is equal to cos phi a minus cos of phi a minus 2 of 2 omega t minus 2 phi va. So what I can do now, I can further simplify it as like this. I can write it as a is equal to, now this is cos phi a minus, this is cos of a minus b. Okay, and by the way, what is cos of a minus b? Trigonometric identity equal to, that is cos a cos b plus sin a sin b, sin a sin b. Okay, this is cos of a minus b, this is a and this whole thing is b. So cos of a minus b is cos a cos b plus sin a sin b. Using this, we can write a is equal to this cos phi a, it is as it is, cos phi a minus times, now this is cos a minus b, cos a cos b, that is cos phi a into cos of 2 omega t minus 2 phi va. So that is cos a cos b. Okay, plus sin a sin b, plus sin a sin b. That's it. So further simplification gives a equal to cos phi a, I will multiply with this minus term, minus cos phi a into cos of 2 omega t minus 2 phi va minus plus is minus sin phi a sin of 2 omega t minus 2 phi va. What we will do, we will take cos phi a common in both terms. So this is cos phi a, what is inside is 1 minus cos of 2 omega t minus 2 phi va minus, this is second term, sin phi a into sin of 2 omega t minus 2 phi va. Let us call this equation as equation 2. This is the mathematical expression for a, that a is equal to cos phi a times 1 minus cos of 2 omega t minus 2 phi va minus sin phi a into sin of 2 omega t minus 2 phi va. Later on we will substitute this a in equation 1 which we have previously written. So this is part A. Okay, in that equation what is b now? We already know b is 2 sin of, actually that is 2 b is we have 2 vb ib, then sine of, it's like this. The equation is already with you, you can write down. So b is 2 sine of omega t minus 120 degrees minus 5 vb into sine of omega t minus 120 degrees minus 5 ib. This b we get from equation 1 which is already with you. Now here also this is 2 sine A sine B, and 2 sine A sine B is cos of A minus B minus cos of A plus B. So therefore B is equal to cos of A. A is omega t minus 120 degrees minus 5VB minus B. B is omega t, then minus and minus plus 120 degrees, minus and minus plus 5IB. Minus cos of A plus B. Minus cos of A is omega t minus 120 degrees minus 5VB plus omega t minus 120 degrees minus 5IB. Okay. Now, further simplification gives B equal to cos of this omega t, and omega t goes, plus 120 minus 120 goes. So I get 5IB minus 5VB. 5IB minus 5VB minus cos of omega t plus omega t is 2 omega t minus 120 degrees minus 120 degrees is minus 240 degrees, then minus 5IB minus 5VB. Okay, let us call this phase angle, phase difference, 5IB minus 5VB equal to 5B. So 5B is basically the phase difference between current IB and voltage VB. Between current IB and voltage VB, the phase angle is 5B. So from this, what is, by the way, 5IB? 5IB is 5B plus 5VB. Substitute this in above equation. So B is equal to cos of 5IB minus 5VB, 5IB minus 5VB, we will denote by 5B as per this equation, minus cos of, what I will do, I will take 2 common, so omega t minus 1, 2 times omega t minus 120 degrees, minus 5IB. What is 5IB? It is 5B plus 5VB. So it is minus 5B minus 5VB. Then you have your own minus 5VB. Okay, that's it. So further simplification gives B equal to cos of 5B minus cos times 2 of omega t minus 120 degrees minus 5B minus 5VB minus 5VB is minus 2 5VB. So B is equal to cos of 5B minus cos of, let us change the signs. This will become minus 2 times omega t minus 120 degrees. This was minus, it will become plus. This was minus, this will become plus. Now let us rearrange terms in this. So B is equal to cos of 5B minus cos of, first of all I will write this 5B itself. I will write 5B. Okay, then minus this thing, 2 of omega t minus 120 degrees minus 2 phi VB. Okay, yes. Just this and then this. So what I have done, I have written 5B first, and then I have written this term first and then this term. Minus into plus is minus, minus into minus is plus again. Okay, so this is again cos of A minus cos of B. This is A and this whole thing is B. What is cos of A minus B? Cos of A minus B is cos A cos B plus sin A sin B. So we can write it like this then. We'll rub up to this, we'll preserve this, because now here we can use trigonometric identity cos of A minus B, which is cos A cos B plus sin A sin B. So therefore B is equal to, first term is cos 5B, let's keep it like this, minus times cos A cos B. Cos A is cos 5B into cos B. cos of, this is b, 2 omega t minus 120 degrees minus 2 phi vb. Okay, minus sin a sin b minus, plus sin a sin b, sin a into sin b, b is 2 of omega t minus 120 degrees minus 2 phi vb. Okay, now further simplification will give b equal to cos phi b minus cos phi b into cos of 2 times omega t minus 120 degrees minus 2 phi vb minus plus is minus sin phi b into sin of 2 times omega t minus 120 degrees minus 2 phi vb. Okay, just like I have done in term A, there I took cos phi a common, here I will take cos phi b common. When I take cos phi b common, inside I will get 1 minus this term cos of 2 times omega t minus 120 degrees minus 2 phi vb. Okay, then minus sin phi b into sin of 2 into omega t minus 120 degrees minus 2 phi vb. Let me verify whether I have done it correctly or not. It's cos phi b times 1 minus cos of 2 omega t minus 120 degrees minus 2. Okay, minus sin phi b. Yeah, it's absolutely right. Let me call this equation as equation 3. This is the equation for b. Now similarly, I will get the equation for c. Okay, now what is our c? C is equal to 2 sine of, from equation 1 you can get c, it's 2 sine of omega t plus 120 degrees minus 5 vc into sine of omega t plus 120 degrees minus 5 ic. Okay, so this is again 2 sine a sine b, which is equal to sine cos of a minus b minus cos of a plus b. This is equal to cos of a is this thing, minus b minus cos of a plus b plus okay, so this is equal to cos of this omega t, and omega t goes plus 120 minus 120 goes, so it is 5 ic minus 5 vc minus cos of omega t plus omega t is 2 omega t plus 120 plus 120 is 240 degrees minus first 5 ic term, then minus 5 vc term. Okay, now as we have done in previous two cases, here also let us assume this phase difference is 5 ic minus 5 vc is equal to 5c. 5c is the phase difference or phase angle between line current ic and line to neutral voltage vc. Okay, so from this 5 ic you can find as equal to 5c plus 5 vc. So therefore, substituting in equations, in this equation, c is equal to cos of, what is 5 ic minus 5 vc, that is 5c minus cos of, I will take this 2 common from these two terms, I will get omega t plus 120 degrees, cos of 2 of omega t plus 120 degrees minus pi ic. What is pi ic? That is minus 5c minus 5 vc. Then it has its own minus 5 vc. Okay, now c is equal to cos of 5c minus cos of 2 times omega t plus 120 degrees minus 5c minus 5c minus 5c is 5 vc minus 5 vc is 2 times 5 vc. Okay, So C is equal to cos of phi C minus cos. Let me change the signs. This is minus times 2 omega t plus 120 degrees. This minus will become plus phi C, and this will also become plus 2 phi VC. So with this, I can now write equation like this. I can write it like this: C equal to cos phi C minus cos of, I will first of all write phi C, okay, then minus times 2 of omega t plus 120 degrees minus 2 phi VC, okay, because minus into plus is minus, that is this term, okay, and minus minus into minus is plus, that is this term. So this is again cos of a minus b. So this is your a and this is b. Cos of a minus b is cos a cos b plus sin a sin b. Using that trigonometric identity, that is cos of a minus b equal to cos a cos b plus sin a sin b, we can get C equal to cos of phi C minus times cos of a minus b, which is cos a cos b, that is cos a is phi C, into cos b, b is this whole thing, 2 times omega t plus 120 degrees minus 2 phi VC plus sin a sin b. Let me use this plus sin a is this into sin b, sin of 2 of omega t plus 120 degrees minus 2 phi VC, whole thing. So let us write it like this: cos of phi C minus, I will write first term cos phi C into cos of 2 of omega t plus 120 degrees minus 2 phi VC, and then minus plus is minus sin phi C into sin of 2 of omega t plus 120 degrees minus 2 phi VC. Right. What I will do, just as I have done in case of A and B, in case of C also I will take cos phi C common. So this is cos phi C times 1 minus, what is inside, cos of 2 of omega t plus 120 degrees minus 2 phi VC, then minus this term sin phi C into sin of 2 of omega t plus 120 degrees minus 2 phi VC. Let us call this equation as equation 4. Now we have got equations for A, that's equation 2, equation 3 is for B, and equation 4 is for C. Now putting equations 2, 3 and 4 in equation 1. By the way, what is your equation 1? For your reference, I will write equation 1 again. You are supposed to write that in the beginning and preserve that. What is your equation 1? Your equation 1 is this: Pt, instantaneous power, is equal to VAIA into A plus VBIB into B plus VCIC into C, where you know A is what is A? 2 sine of omega t minus phi VB into sine of omega t minus phi I, 2 sine of omega t minus phi VA into sine of omega t minus phi I. Similarly, B is 2 sine of omega t minus phi VB minus 120 degrees into sine of omega t minus 120 degrees minus phi IA. And C is 2 sine of omega t plus 120 degrees minus phi VC into sine of omega t plus 120 degrees minus phi IC. Okay. Now we have equations for A, we have equations for B, we have equations for C. Okay. So substituting A, B and C from which equations? From equations 2, 3 and 4. Let us call this is same equation, equation 1. in equation 1, we get, what do we get? We get three-phase instantaneous power equal to VAIA into A. By the way, what is A? A we have already computed. A is cos of phi A times 1 minus cos of 2 omega t minus 2 phi VA minus VAIA into sine of phi A into sine of 2 omega t minus 2 phi VA. So this is VA into A. A is this plus this. Then plus VB into VBIB into B. Okay. What is B? Then plus, I will write plus VBIB into B. B is cos phi B times 1 minus cos of 2 times omega t minus 120 degrees minus 2 phi VB. Okay. Right. Minus VBIB sine phi B into sine of 2 of omega t minus 120 degrees minus 2 phi VB. Okay. Then we have plus VCIC into C, and we have already computed C plus VCIC, just few moments back we computed C, that is given in equation 4. And what is C? C is cos phi C times 1 minus cos of this 2 of omega t. Instead of minus 120 degrees, it is plus 120 degrees minus 2 phi VC. Okay, minus VCIC times sine term. Sine term is this phi, sine phi C is sine of 2 of omega t plus 120 degrees minus 2 phi VC. Nice. So this is the final equation for instantaneous value of power in three-phase system. Of course, three-phase unbalanced system where there is unbalance in both voltages as well as currents. Now, as far as this first term of phase A, this is the instantaneous power of phase A, these two terms. VAIA cos phi A times 1 minus cos of 2 omega t minus 2 phi VA minus VAIA into sine phi A sine of 2 omega t minus 2 phi VA. This is the instantaneous power of phase A. Instantaneous power in phase B is given by this term, and instantaneous power in phase C is given by this term. Now, as far as instantaneous power in phase A is concerned, it has two components. This is active component, PA active, and this is reactive component, PA reactive. Similarly, in phase B, these are the two terms representing instantaneous power. This is active power, PB active, this whole term, and this whole term is reactive power, PB reactive. And similarly, the power in phase C is given by these two terms. The first term, this whole term, represents active, instantaneous active power, PC active, and this second term represents instantaneous reactive power in phase C, PC reactive. So therefore, we can write PT is equal to PA active plus PB active plus PC active plus PA reactive plus PB reactive plus PC reactive. Very interesting. So that means the instantaneous power in a three-phase circuit is sum of three instantaneous active powers, PA active plus PB active plus PC active, which are given by first terms of this equation, plus PA reactive, instantaneous reactive powers in the three phases, PA reactive plus PB reactive plus PC reactive, which are given by second terms of this equation. this term involving sine, this term and this term. Okay. Now, as far as if you find the three-phase instantaneous power, P three-phase T, which is same as PT, we can say it is equal to PA plus PB bar, PA bar plus PB bar plus PC bar plus PA this sign plus PB this sign plus PC sign. Now, as far as these terms are concerned, they represent average power, average three-phase power. And these terms represent these are average three-phase power components. And these three terms represent oscillating components. Oscillating components. Okay. Now, as far as this PA bar is concerned, PA bar is average power in phase A. Now, you just few moments back you have written mathematical expression for PT. For phase A it was like this: VAIA cos phi A times 1 minus cos of 2 omega t minus 2 phi VA minus VAIA sin phi A into sine of 2 omega t minus 2 phi VA, then plus similarly VBIB dash 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 plus VCIC dash dash dash. Now, as far as phase A is concerned, this is instantaneous active power. You have already written this. First term is instantaneous active power, PA active. और इसका average value अगर आप निकालेंगे, how can you find average value of this instantaneous active power? You can find average value by by integrating it from 1 to t, 0 to t, 1 to t, PA active dt. जब आप इसको integrate करेंगे, this term becomes 0, so this is VAIA cos phi A. So this comes out to be VAIA cos phi A. Simple. So similarly, what is the instantaneous, what is the average power in phase carried by phase B? That will be in a similar way equal to VBIB cos phi B. And what will be the average power carried by phase C? That is capital PC. That is equal to VCIC cos phi C. So therefore, what is total average? What is total three-phase average power delivered from three-phase source to three-phase load? That is given by P. We can write that as capital P, P three-phase. That is equal to PA bar plus PB bar plus PC bar, average power of all the sum of average powers of all the three phases. So total average power delivered to load is this. It is given by, I will write total average power delivered to load is VAIA cos phi A plus VBIB cos phi B plus VCIC cos phi C. Very important relation. This is the total average power which is delivered from three-phase source to three-phase load. Say for example, it may be 100 kilowatts, it may be 1 megawatt, depending upon the power delivered to the load and load capacity. Does it mean that three-phase power which is delivered to load does not have any oscillating components? No, that's wrong. The three-phase power, instantaneous power, is given by sum of these three terms, which is the average three-phase power, which is equal to VAIA cos phi A plus VBIB cos phi B plus VCIC cos phi C, plus it has got oscillating components also. And how do we find those oscillating components? Let me give you the mathematical expression for oscillating components. As far as this oscillating component PA is concerned, this PA is given by minus times VAIA cos of 2 omega t minus phi VA minus phi IA. Where from I got it? I got it from equation 1. Equation 1 you have already written. Equation 1 को जब आपने solve किया, you put equations 2, 3 and 4 in equation 1 and you got that final equation जहाँ से हमने ये लिखा. वहाँ पे if you go back to that equation, you will find that the ऑसिलेटिंग कंपोनेंट वो कंपोनेंट होता है जिसमें 2 cos of 2 omega t टर्म है. Okay, let me write that equation again. You know, pt was equal to, for example, it was given by va ia cos phi a times 1 minus cos of 2 omega t minus 2 phi va minus va ia sin phi a sin of 2 omega t minus 2 phi va. This is, ये आपको, when you integrate this will give you average power. You have already written few moments back, that is this VAIA cos phi A. Similarly, there will be VBIB cos phi B, so on, and plus VC. I am not writing all terms, VCIC cos phi C, so on. I am not writing that. I am considering only phase A. And this sine of 2 omega t minus 2 phi VA means it's the oscillating term in this power. Okay, it is actually given by VAIA sine of 2 omega t minus 2 phi VA. Okay, जब आप 2 phi VA का वैल्यू पुट करोगे यहाँ, it will become after one or two steps which I have already done. You can see after equation 1, after equation 4, after a couple of steps. If you go through your notes, you write all the steps, whatever I have written the previous steps, you will come up with this equation. This PA will be VAIA. Of course, why minus? Because it is minus here. VAIA and its oscillating term. See, this is the active power and this is the reactive power. Active power में भी अब दो terms है. एक है average. Average in phase A is VAIA cos phi A. That is equal to PA. Similarly, average in phase B is PB, which is VBIB cos phi B. Average power of phase C is PC, which is VCIC cos phi C. Plus oscillating term also. There is oscillating term also. Where is that oscillating term? That is this minus VAIA cos of 2 omega t minus 2 phi VA. Okay, it is oscillating term. If you write PA from this equation, minus VAIA cos of 2 omega t minus 2 phi VA. We know that phi A is equal to phi IA is equal to phi A plus phi VA. Okay, यहाँ से अगर आप phi VA इसमें substitute करोगे, phi VA will be equal to this minus this, and after substituting in this equation, you will get PA equal to minus VAIA cos of 2 omega t minus 2. Minus VAIA cos of 2 omega t minus 2 phi VA minus phi IA. I have already derived it. It's already there. You can check it. Similarly, what is PB? Oscillating component of power in phase B. PB, if you find, PB is given by this equation, minus VBIB cos of 2 times omega t minus 120 degrees minus phi VB minus phi IB. And PC, oscillating term, is minus VCIC cos of 2 of omega t plus 120 degrees minus phi VC minus phi IC. It's already there. Don't wonder that where from I have got. If you go back to that equation, okay, which just few steps back I have derived, I have got it from there. So that equation, power equation, has these terms: constant, average term, and oscillating term. Average terms are PA, PB, PC, which is VAIA cos phi A plus VBIB cos phi B plus VCIC cos phi C. And what are the oscillating terms? Oscillating terms from that equation. This is PA, this is PB, this is PC. Now, if you add these oscillating terms, let us see whether they add up to 0 or not. The sum of oscillating terms PA plus PB plus PC. What is your PA term? It is minus VAIA cos of 2 omega t minus phi VA minus phi IA plus PB. PB आपका ये है minus VBIB cos of 2 times omega t minus 120 degrees minus phi VB minus phi IB plus PC. PC आपकी ये है minus VC IC cos of 2 times omega t plus 120 degrees minus 5 EC minus 5 IC. Remember, if you add up these three terms, oscillating terms of the active power, these are active power terms, not reactive power. See, your active power has a constant average term and oscillating term. Okay, average term you have already written, that is PA in phase A, which is equal to VAI cos phi. In phase B, that is in phase A, that is PA bar, which is equal to VAIA cos phi A. In phase B, that is PB bar, which is equal to VBIB cos phi B, and in phase C, that is PC bar, which is equal to VCIC cos phi C. And total average power is sum of these three terms, VAIA cos phi A plus VBIB cos phi B plus VCIC cos phi C. And in addition to these constant terms, you have oscillating terms also. Oscillating term in phase A power is this, and the instantaneous power in phase B has this oscillating term, and instantaneous power in phase C has this oscillating term. If you add up these, they will not add up to 0. It will not be equal to 0. Okay? So therefore, it's a very important relation. Okay? This relation tells us that total active power, I mean PT, total power, is equal to PA plus PB plus PC, that is average sum of average powers plus sum of oscillating terms of powers. PA oscillating plus PB oscillating plus PC oscillating. What is this? This is PA is VAIA cos phi A plus PB is VBIB cos phi B plus PC is VCIC cos phi C plus PA. PA is the oscillating term of the power. This is the average power. And this is the oscillating term of power. And what is that? That is minus VAIA cos of 2 omega t minus 5VA minus 5IA. That is this. Minus plus PB. PB is this. Minus VBIB cos of 2 times omega t minus 120 degrees minus 5EB minus 5IB. Minus, actually it is plus PC, and plus PC is this minus VCIC cos of 2 of omega t plus 120 degrees minus 5EC minus 5IC. And mind it, these three oscillating terms, when you add them up, as I have added them up here, their sum does not become equal to 0. That means there is oscillating term also. So this is different from instantaneous active power in a three-phase balanced system. You remember in last couple of lectures we were discussing a balanced three-phase system. In a balanced three-phase system, what was total active instantaneous power? That was 3VI cos phi. Was there any oscillating term? No, that was constant. The average power or the total power delivered by source to the load is constant, 3VI cos phi. And I told you that that is one of the advantages of three-phase systems over single-phase system, because single-phase system delivers a power to the single-phase load which has got oscillating term, which is not constant in nature, which is oscillating in nature, and that causes torque pulsations, vibrations in single-phase motors. Whereas if you feed a three-phase AC motor by a three-phase balanced supply, remember I am using the word balanced three-phase supply, constant power is delivered to the three-phase motor, and because of constant power 3VI cos phi, there is no oscillating term. It's not oscillate, it's absolutely constant. अगर इसका graph आप plot करेंगे, it is constant like this. It does not result in any torque pulsations or vibrations of motor. But what happens when your three-phase balanced system becomes three-phase unbalanced system? As soon as there is unbalanced three-phase system, where there is unbalance in three-phase voltages as well as three-phase currents, your power delivered to the load is no longer constant. The power delivered to the load is PA plus PB plus PC plus oscillating term. These are constant average terms, but there are oscillating terms also. PA plus PB plus PC. And these oscillating terms, they don't add up to 0. That means in addition to constant power, I mean power which is delivered to load, this power is not constant like this, as was the case of a balanced three-phase system. It will be oscillating something like this. It will be oscillating three-phase power like this. It will also have oscillations. So therefore you will lose the advantage of a three-phase balance system. What was three-phase balance system advantage over single-phase system? That it was delivering absolutely constant power to the load, and if the load was a motor, the motor was developing a smooth torque, pulsation free torque. But as soon as your system becomes unbalanced, the three-phase power no doubt is delivered to the load, but that power is having oscillations also. It is not constant like this. It is oscillating power, and your induction motor or AC motor will again start developing torque, pulsations, vibrations, and all that. Okay, so this is what balance does to your power. It changes your power from constant term to oscillating term. Okay, this was about active power. Now, I think I should stop here. Inshallah, in our next lecture, we will discuss about reactive power, three-phase reactive power, which is delivered to the load, instantaneous reactive power. So I end up my lecture here today. Advise you all to go through this lecture, and in case of any difficulties, please get connected to me. Thank you.